We're going to skip ahead here now. We're going to skip surface area and lateral surface area and total surface area. We just don't have time to do it, and that's something that you can find out later on when you need it. We're going to talk about volume. And what volume is the space inside a figure. If you were to think of how much air is inside the room that you're in, that's the volume of air that's in it. It's a three-dimensional thing, and the units are always cubic then. So if it's the dimensions are in inches, it'd be cubic inches. Or meters, it'd be cubic meters if it's a volume. Just like areas are always square units. We're going to look at prisms today. And what a prism is it's a figure that has two parallel sides, and then those are called the bases, and then four other sides. And so some real similar ones, and they'll be a little bit tough to show up here probably, but if we look at this first one, it's really big, but you can see that what that is, you call that a cube, right? Each one of the dimensions along here are exactly the same. So we have a cube. We have something like this one. This is what's called a rectangular prism. You can see the two bases are these two sides, okay, in this case. And sometimes for volume, it really doesn't make any difference. I could call this side down here on the bottom, and this side up here on the top, I could call those the bases. It makes no difference in finding volume. But that's called a rectangular prism. Then we have one that looks like this, that you can see these two triangles on the end are parallel to each other, and then the other sides aren't. That's called a triangular prism. Okay, and there's lots of other ones. Here's one. You can guess by the shape of the base. That determines what type of prism it is. That's called a hexagonal prism. Okay, for all of them, the formula for finding the volume is pretty straightforward. The volume is just the area of the base times the height of the prism, which is the distance between the two bases. And so if we were to start out looking at a cube, okay, and all of the dimensions are the same. So let's say I had a cube. Okay, and let's say all of these were 3 inches, 3 inches, 3 inches, 3 inches, 3 inches, 3 inches, and so on, right? All those dimensions are 3 inches. We can look at that. Here's the base of my figure. That one and this one up here, those are the bases. Those are the parallel sides. I could choose other ones, but again, it makes no difference. All I do then to find the volume is I find the area of this base. Well, the area of a square, we talked about before, is 3 times 3, base times the one side squared. So it's going to be 3 times 3, that's the area of the base. And then the height is the distance between those two bases, which in this case is 3. Multiply that out, and we get 27 inches cubed. That's the volume of the prism of that cube. Just a shorter version of it, it's area of the base times the height. There's really our formula that we use. But this is what it means up here. Okay? If you were to look at a rectangular prism, let's say we had a rectangle. Let's see if I can draw this. It goes back here like this. Pretty artsy for me to be doing stuff like this. Okay? Not all that good, but too bad. Let's say that this is, I don't know, let's say this is 4 centimeters, this is 12 centimeters, and the height here is 3 centimeters. Okay, so again, if I look at, here's my base, that's the bottom, it's 4 by 12. Area of a rectangle was length times width. So volume is going to be 4 times 12, that's the area of the base, times the height, which is 3. You work that out, 4 times 12 is 48. 48 times 3 is 144 centimeters cubed. There is the volume of that prism. Okay? So let's look at a couple examples I have printed out that kind of look like what's on your assignment. Let's look at one like this. Okay, let me zoom this in a little bit. Okay, so this is a triangular prism. You can see that this triangular side is parallel to this. So here's my base down here. This little triangle down here on the bottom. Okay, and if you remember, the area of a triangle is 1/2 base of the triangle times its height. And so if I look from here to here is 12 feet, isn't it? That's the base of the triangle. The height of it is this length, which is 4.5. So the volume of this is going to be 1/2 the base, which is 12, times the height of the triangle, which is 4.5. So there's the area of the base, 12 times 4.5 divided by 2, and then times the height of the prism, which is 4. And then it's just a matter of putting that in your calculator and working it out. 1/2 of 12 is 6. And here, we'll just work it out. Clear that out of there. So 0.5 times 12 times 4.5 times 4. 108. So the volume is going to be 108. And let's see, these are feet, so that's cubic feet. Okay. Look at this one now. Here's a trapezoid. So what do we know? Well, we talked about the area of a trapezoid. Area of a trapezoid was 1/2 the sum of the bases times the height. So if we look at this trapezoid, here's base 1, here's base 2. Well, this is the same as that length, so this is 7. The height is this distance, which is 3.5. So the area is, their volume then is going to equal the area of this base, which is 1/2 times the height, which is 3.5, times the sum of the two bases, 7 plus 3. So there's the area of that base, of that trapezoid, times the height of the prism, which is the distance between those two trapezoids, which in this case is 10. And so again, it's just 0.5 times 3.5 times parentheses 7 plus 3, or you can just add them and get 10 times 10. And I get 175, and these are centimeters, so it's cubic centimeters. There's the volume of that prism. One more example, let's do one of these rectangular prisms like this. Okay, so if I were to look at that, here's my base. Volume then is the area of the base. It's a rectangle, 5 times 9. That's the area of the base times the height of it, which is 10. So 45 times 10, 450 kilometers cubed. There's the volume of that. All right, that's what your assignment is. Please ask questions if you have any.